Let's look at factoring by grouping to factor some cubic and quartic polynomials. So for example, 15x cubed minus 10x squared plus 6x minus 4. So first, if possible, we would like to factor out a GCF, a greatest common factor, but I don't have one here. Then we'll group the first two and last two terms. And I like to do that by putting a vertical line to kind of split the four terms in half. And we will factor a greatest common factor out of each pair. So in the first pair, 15x cubed negative 10x squared, my GCF is 5x squared. 15x cubed divided by 5x squared is 3x. Negative 10x squared divided by 5x squared is negative 2. Then we'll look at my second pair, 6x and minus 4. My GCF here is 2 because that third term is positive, is plus 2. And then 6x divided by 2 is 3x. Negative 4 divided by 2 is negative 2. Then we will factor out the common binomial term. And we see this common binomial term here, 3x minus 2. So I'll factor that out as a greatest common factor. And then in my second parentheses, we are left with the GCFs that we factored out, the 5x squared plus 2. Now, any nonlinear factors, like my second factor here, 5x squared plus 2, we'd like to continue factoring if we can, but this is a binomial that is not a difference of squares. There's no GCF, so we are done factoring. So check if any factor can be factored further. We could not. Example 2. Let's look at 2x to the fourth plus 5x cubed plus 2x squared plus 5x. So looking at these four terms, is there a GCF? Yes, we can factor out an x. When we do that, we have 2x cubed plus 5x squared plus 2x plus 5. So now we have four terms. We can try to use factoring by grouping. We'll split the terms in half. And now I will look for a GCF out of the first two terms, the 2x cubed plus 5x squared. My GCF there is x squared. 2x cubed divided by x squared is 2x. 5x squared divided by x squared is positive 5. Then we'll look at my third and fourth term, 2x plus 5. So I don't see an obvious GCF, and in those cases, 1 is always a greatest common factor. So I'll put 1, and my third term is positive. And 2x divided by 1 is 2x. 5 divided by 1 is 5. And of course, we still have our original greatest common factor of x. So inside where we were factoring out our GCFs, we do see a common binomial term which we can factor out. So 2x plus 5. And then in our second parentheses, we'll put the GCFs that we factored out, the x squared plus 1. And then we have our original greatest common factor that we factored out of x. So our second example factors 2x times 2x plus 5 times x squared plus 1. Let's look at one more example. 3x to the fourth plus x cubed minus 48x squared minus 16x. So do we have a GCF? Yes, we can factor out an x. When we do that, we're left with 3x cubed plus x squared minus 48x minus 16. So I'll split the first two and third and fourth terms, separate them. So first two terms, 3x cubed, x squared. My GCF, my greatest common factor, is x squared. When I divide 3x cubed plus x squared by x squared, I get 3x plus 1. Negative 48x, negative 16. My greatest common factor is 16, and because my third term is negative, I also factor out the negative. And then when I take negative 48x and divide it by negative 16, I get 3x, and then negative 16 divided by negative 16 is positive 1. And of course, we still have our original greatest common factor of x. Now inside the parentheses we have a common binomial term, that 3x plus 1, let's factor that out. And then in our second parentheses we'll have x squared minus 16. And we have our original greatest common factor of x. And now we do want to see if we can factor further. X does not factor further, 3x plus 1 does not factor further. But x squared minus 16 is a difference of 2 squares, so I'll separate it into 2 parentheses. The square root of x squared is x. The square root of 16 is 4. One gets a plus, one gets a minus. And then I also have my other factors, my 3x plus 1 and my x. So example 3, factor 2, x times 3x plus 1 times x plus 4 times x minus 4. And now we are done factoring.